All right, number 2, a plane travels 2.5 kilometers at an angle of 35 degrees to the ground, and then changes direction and travels 5.2 kilometers at an angle of 22 degrees to the ground. What is the angle and direction of the plane's total displacement? So we are initially moving 2.5 kilometers, right, like during the ascent. And during that ascent, we're traveling at an angle of 35 degrees. And then for the second portion of the ascent, right, it's not quite as extreme of an angle, but we'll be moving for a longer period of time at 5.2 kilometers at an angle of 22 degrees. Let's see if I can represent this. So a little bit of a steeper angle, and then not quite as much of a steep angle, but a little bit longer. What is the magnitude and direction of the plane's total displacement? Again, we're trying to find that bad boy right there. So again, this is a triangle, but it is not a right triangle. And so that kind of disallows us from using our normal SOHCAHTOA trigonometric functions. And so what we're going to do is we're going to decompose or resolve this, this triangle into its components. And once we have the individual components, we can add it back together to make a right triangle, right? Which would be super fun. All right, so let's get started because we've got to show a lot of work here. All right, so let's find the x component of that first movement. Again, first displacement times the cosine of the first angle. It's going to be 2.5 kilometers times the cosine of 35 degrees. That ends up being 2 kilometers. Now let's get the y component of the first movement. Again, the first movement, the first displacement, now it's going to be cosine of the first angle, 2.5 kilometers. This time it's going to be sine 35. This ends up being 1.4 kilometers. Now notice, and again, I'm doing this to encourage you guys that even though these calculations take a long time because they're a lot of like small steps, look how this actually ends up being pretty simple once you get kind of the pattern of it. A lot of times in the way we set these up, the y component is going to be the sine because our initial movement, you know, from our perspective, a lot of times it's kind of like going up. That's just kind of how it works out. It doesn't work that way all the time, but a lot of the time your y component is going to involve a sine. But notice that it's always the same displacement, right? The displacement 1, and it's the same angle, theta 1. The only thing that's changing is cosine versus sine. And again, same displacement, same angle. The only difference is sine versus cosine. And so let's break down our second movement, right? This one right here. Let's break down our second movement into its components. And so we'll have, so second displacement multiplied by the cosine of the second theta. That ends up being, it was 5.2 kilometers times the cosine of 22 degrees, which my calculator tells me is 4.8 kilometers. Now the y component of the second movement, second displacement, times the cosine of the second theta. Still 5.2 kilometers multiplied by the sine of 22 degrees, which my calculator tells me 1.9 kilometers. So I have two x components and I have two y components. If I simply add the x components together, I get an x total. If I add the y components together, right here, I'm going to get a y total. And that will allow me to build a right triangle. So let's see, what do these actually end up being? So my x's add up to 6.8 kilometers, and my y's add up to 3.3 kilometers. Handwriting's a little sus, but that's okay. So pretend that's straight. So my x total, 6.8 kilometers, and my y total is going to be 3.3 kilometers. Now notice that my resultant displacement from these first two movements is the same as the resultant of these two sides, right? The hypotenuse of these two sides. This is what we've been able to do. We've been able to construct a right triangle, so we can use our sine, cosine, and Pythagorean theorem skills. And so we'll simply do that. All right, so my resultant is going to be my total x, which was 6.8 kilometers squared plus 3.3 kilometers squared. But then I have to square root that. And that ends up being 7.5 kilometers. 7.5 kilometers. Now I need to find my theta total, like the overall angle. And so again, tangent being opposite over adjacent is going to be the y over the x. So it's going to be tangent arc 3.3 kilometers, because that's the y component, the opposite side compared to my angle, over 6.8 kilometers. And my calculator tells me that this is 26 degrees above the horizontal.